Hello students, how are you? I hope you all are well. So today in this video I am going to start the next part of this chapter number 5th, heat. So dear students, I had already started this chapter in my previous video and I had explained you the concept of heat, the definition of heat, the term temperature, the effects of heat and also the thermal expansion. And today I am going to start the next portion, that is good conductors and bad conductors of heat. So now we are going to learn that what are the good conductors and what are the bad conductors of heat. So see this one carefully. So you can see the definition: just like good conductors and bad conductors of electricity, there are good conductors and bad conductors of heat also. So means good conductors means those substances through which the heat can easily passes are called the good conductors. So you can see the substance which allow the heat energy to pass through them easily are called good conductors of heat. Means those substances through which the heat energy can be passed easily. Those substances are called the good conductors of heat. So you can see metals are the good conductors of heat. So you can see the examples are given to us: iron, aluminium, mercury, copper and so on are the good conductors of heat. So even in metals, some metals transfer the heat faster than the others. So you can see some metals conduct the heat faster than the others. Good conductors of heat are also known as heat conductors. So for example, copper conducts heat faster than aluminium and then aluminium conduct heat faster than iron. So means in metals, some metals can transfer heat faster than the others. Okay, now the next is bad conductors or the insulators. So the bad conductors are those substances through which the heat cannot be easily passed. So you can see a substance which does not allow heat to pass through it is called the bad conductors or poor conductors or insulator of heat. So for example, rubber, wood, plastic, wool, liquid and so on are the examples of bad conductors. Means in these substances the heat cannot be passed. Oh, and now you can see this one also. Air is also a bad conductor of heat. Means in air also doesn't allow the heat to transfer through it easily. So means air is also a bad conductor of heat. So like the same way, vacuum is also heat insulator. So these are the examples are given to us of those substances. Those are bad conductors of heat. So means, or simply we can say that the insulators. So okay, now we are going to learn some real world applications related to the insulators and conductors. Okay, first of all, first examples we are going to learn from the summer season. Okay, now in the summer season you can see the first point you can see here. So this picture is shown to you. You can see here an ice slab is wrapped with this cloth. So you can see why. Because of ice slab, sellers keep ice covered with insulating cloth or jute bags so that it may not melt quickly with heat. And you can see the ice sellers are covering the ice slabs with the insulation cloth or jute bags. Why? Because if you can see the air inside the threads of this cloth. So you can see this is a cloth and the air inside the threads of this cloth gives insulation to the ice. Means it doesn't allow the heat transfer easily. Means it doesn't allow the outside heat of this cloth easily transfer inside. So that is why the ice may not melt quickly in the summer season. So you can see the next one also. So this picture is shown of a refrigerator. So you can see the water coolers, refrigerators and ice boxes are kept insulated from heat by filling glass, wool, plastic or some other poor conductors of heat in their walls so that inside temperatures remains low. Means you can see in this picture, you can see in a refrigerator it has a double wall. So you can see this is outside wall and this is inside wall, and this gap is left, you can see here, and in this gap the plastic or glass wool or some other poor conductors are filled. So in this gap, suppose this glass wool is filled in this gap. So why? Because of in this gap the glass wool when filled, then it gives insulation to this refrigerator. Means it doesn't allow the heat transfer easily from inside to outside or from outside to inside. So that is why temperature remains low inside the refrigerator for a long time. So okay, you can see the next example is of an ice cream vendor. So ice cream vendors use ice cream containers having double walls of metal. So these containers have double walls. So means there is a gap inside the walls and the ice cream vendors fill this gap with ice. Because of ice gives insulation, it doesn't allow the heat transfer easily, so that is why ice cream gives insulation to the ice cream and prevent the ice cream from melting. So that is why inside these double walls the gap is filled with ice, and ice behaves as insulator and it doesn't allow the easily transfer of heat from the outside to inside. So temperature remains same for a long duration inside this container. So okay, now you can see the next example is given of this pipe of air conditioner. You can see this pipe is wrapped or covered with this foam. Why? Again the same thing, because the foam is an insulator and it doesn't allow the heat transfer from the outside to inside this pipe, and the temperature inside the pipe or the gas inside the pipe doesn't affected by this outside temperature. So you can see pipes of air conditioners are wrapped with foam so that the outside temperature does not affect the gas in them. So okay, now the next examples are related to the winter season. So the first example is here. You can see the blankets and the quilts keep us warm in the winter. Why? Because of the blankets and the quilts keep air trapped in them. And we know that air and wool both are bad conductors of heat. So that is why they do not allow the heat of our body to flow out of the blanket or quilt. So we feel warm. So okay, the same thing is also here in the second example. You can see during the winter season in a cold weather we are wearing woolen clothes. So you can see here some pictures of woolen clothes are given to us. So in cold weather we are wearing woolen clothes. Why? Because of wool is a bad conductor of heat. So wool keeps air trapped in it, and we know that air is a bad conductor of heat also. So that is why wool doesn't allow our body heat to lose. Okay, in the third example you can see a picture of a tiffin is shown to you. So you can see this is a tiffin box, and these tiffin boxes are specially wrapped with thermocol. Why? Because of thermocol is also a bad conductor of heat, and that is why when we are keeping our food in these kind of boxes, thermocol doesn't allow the heat to lose easily. So you can see the hot food is kept trapped in thermocol boxes, so heat is no lost. Okay, now see the last example that is given of geyser. You can see the walls of geyser used for storing hot water for long duration is filled with glasswool, foam, cork, etc. So heat is no lost. So you can see the picture of the geyser here also, and this geyser is also having two walls. It means it has two walls, and there is a gap inside these walls, and these walls are filled with glass wool or foam. This glass wool is an insulator and it doesn't allow the heat inside this water to outside, so the water remains hot for long time. Okay, now the next concept is methods of heat transfer. So okay, before starting the methods we have to understand that what is the meaning of heat transfer. In our previous classes we had studied that the heat always transfer from a body at a higher temperature to a body at a lower temperature. So if we are keeping the two bodies closer and one body has a higher temperature and the other body means second body has a lower temperature, then the heat starts flowing from a body at a higher temperature to a lower temperature till both the bodies attain the same temperature. So that is why this definition is given to us. You can see we know that heat transfers from an object at a higher temperature to another at a lower temperature till both attains the same temperature. So means heat always flows from a body at a higher temperature to a body at a lower temperature. Okay, now you can see these are the methods of transfer of heat are given to us. The first method is conduction. So this process mainly takes place in the case of solids. Next is convection. So the convection process takes place in the case of liquid or gases. And the last is radiation. So you can see here nil is written. It means radiation doesn't require any medium to travel. So okay, I will explain to you one by one in detail. So okay, now you can see the first process of transfer of heat is conduction. So it mainly happens in the case of solids. Okay, you can see it is a process of transfer of heat from one end to the other end of the object such that the heat flows from the particle to particle. It means in the case of solids, heat flows from particle to particle. Means there is no any actual movement of the particles. Particles are always remains at their places and the heat flows from the particle to particle. Okay, I will explain to you with the help of this clip. So see carefully. Okay, now you can see, suppose this is a rod and inside this rod you can see the arrangement of the particles, and you can see from this side we are holding this rod and from this side we are heating this rod. And now you can see, first of all, Okay, you can see the particles are in a form of motion because of they are always vibrate on their places. You can see all the particles are vibrating. And now we are heating the rod from this end, and these particles are getting the heat from the source, and they starts vibrating with more energy, and through this vibration they are passing the heat to the particles which are exactly near to that particles. So it means the particles which are near to the fire getting more amount of energy, then they starts more vigorously, and then they passes the heat to the particles which are exactly near to them, and in this way the particles are transferring the heat from particle to particle, and there is no any actual movement of the particles, means particles are not leaving their place, only the heat transfers from the particle to the particle. Now you can see the same example is taken also here. So you can see this is the rod, and one end of the rod is heated, and then heat starts flowing from this direction to this direction. So means the heat flows from the particle to the particle. So that is why an important line is written here. You can see heat from one particle is handed over to the other particle, and so on. Means those particles which are near to the fire, they are getting heat, and then they start vibrating with more amount of energy, and then they passes this energy to the particles which are exactly near to them. So in this way the heat transfer from the particle to the particle. So this demonstration you can see also here the given to you. So you should read this one by yourself also, because of the same explanation is given to you. So this is the process of conduction. Okay, now the next process of heat transfer is convection. So this process mainly takes place in the case of liquid and gases. Because of in the case of liquid and gases, the particles are loosely packed, means they are far apart from each other. So that is why actual movement of the particles takes place for transferring the heat. So okay, now you can see. So it is a process of heat transfer by way of actual motion of the particles of a medium being heated. Means in this case the heat is transferred by the actual motion of the particles. Means in this case the particle actually moves. Actually means moves means they are leaving their places. So I will also show you with the help of this clip. So see this one also carefully. So okay, now you can see in this clip, first of all you can see the arrangement of the molecules. You can see in the case of liquid and gases, the molecules are far apart from each other. So you can see it has a less intermolecular force of attraction between the particles. Okay, now see all the particles are in the form of motion. You can see in the case of liquid and gases. So you can see the particles are moving. So now you can see, so all the particles are in a form of motion. So now you can see from this side we are heating the particles, or we are heating this liquid or gas. So all the particles which are near to the heat, they are getting the heat. These particles which are near to the fire, they are getting the heat, and because of they are getting the heat, their density decreases, and that is why they become lighter and they goes in the upward direction. And the other particles are, now you can see, moving in the downward direction to take their place. So it means now these particles are getting the heat from this fire. The same thing is also happening with these particles also. So because of their density decreases, and then again they gets also lighter, and then they goes in the upward direction. You can see this process continues till the both liquid or till the both gas attaining the same temperature. So this is the process of convection. So in this convection process, or in this clip, we had learned that in the case of liquid and gases, a type of convection current is set up on heating. Liquid and gases expand when heated. Their density near the heat source becomes less. So the particles near the source of heat move up with a faster speed. The particles of the denser medium from the top layer starts moving down. So this process continues till the both liquid attain the same temperature. So I had already shown this one through the clip. So I hope this is also clear to you. So this is a convection process. So okay, now you can see some practical examples are given to us related to this convection current. So you can see this first question is asked to you. Do you have a windows and ventilators in your classroom? Of course, yes. And the next question you can see, why the ventilators are near the ceiling of the room. Okay, you have noticed this thing also. The ventilators are always near the ceiling of the room. And also you can notice the thing that the windows of the rooms are always near to the bottoms. Why? Because of the fresh air is cooler, so it enters through the windows, and the room air is hotter, so it is lighter, and it rises up and leaves the room from the ventilators. So it means this application is also related to the convection current. So okay, now you can see the second example also. So in winter season we use room heaters or blowers, and we are keeping these room heaters on the floor. Why? Because of air near them heats up. This air becomes lighter and rises up. Thus the hot air warms the whole room. So this is also the example of convection current. So okay, now you can see next in your book this activity is given to you. This activity is also showing the convection current. Okay, I am only explaining this activity through this diagram, and you can read the whole explanation also. So okay, you can see first of all this is a transparent box, and you can see there are two circular holes on this box, and here two chimneys are fitted. You can see on these two circular holes, and you can also see this burning candle is placed inside this box, and also you can see on this chimney an incense stick is also lightened here. So okay, now you can see what is happening here. Because of this burning candle, the air inside this box get heated, and because of this air is get heated, so its density again decreases, so it becomes lighter and it rises up. So through this chimney it rises up and goes outside of this box. So that is why it is written here outlet chimney. So okay, now you can see the air outside of this rectangular box is cooler than the air inside this box. So that is why the cooler air is taking place of this hot air by going through this chimney inside this rectangular box. And with the help of the smoke, you can observe that the air is going inside into this rectangular box. So in this way the convection current is set up in the gases also. Okay, in the interesting fact, you can see this hot air balloon. So in different movies or in different videos you have also seen this one, and you can see it also works on the principle of convection current. How you can see a burner heats up the air inside the balloon. You have noticed this thing also. Here is a fire is burnt here, and because of this fire the air inside this balloon get heated, and that's why it become lighter. So it exerts a pressure in the upward direction, means it exerts a force in the upward direction, and that's why this balloon starts flying in the air. So okay, now you can see the last one is the radiation. So this is also the process in which the heat transfers from a hot body to a cold body, but in this case medium is no required, means in the absence of medium even the heat can also flows. So okay, you can see it is a process of transfer of heat from hot object to a cold object even in the absence of a medium. So in fact no medium is required for this type of heat transfer. It means that the heat radiations passes through vacuum also. So heat from the sun reaches the earth through radiation, and you can see also the speed of radiation also. The heat radiation travels with the speed of light in vacuum, that is 3 into 10 raised to power 8 meter per second. So the speed of the radiation is also same to the speed of the light, and you can see the sun is the biggest source of heat. Earth receives heat energy from the sun by the radiations. Heat energy from the sun is transferred to the earth through the space, which has major part as almost vacuum. Means we can understand that the heat can also passes, or heat can also flows in vacuum also. So this is the concept of radiation. Okay, now see the last topic of this chapter. This is a thermos flask, or simply we can say this is a thermos. Okay, many students have seen this one, maybe all the students are using this one also. And what is the use of this thermos? The use of this thermos is, if we are pouring any kind of liquid in it, either it is hot or cold, it is able to maintain the temperature of the liquid same for a very long duration of time. Means if we are carrying a cold water in it, then it remains the cold for a very long duration of time. Or if we are taking any hot liquid in it, then the liquid remains hot for a very long duration of time. So see the definition first of all. It is a special flask which doesn't allow easy transfer of heat by keeping it insulated from the surrounding. So it is popularly known as thermos. So now we are going to learn that why this thermos flask is able to maintain the temperature of any liquid which is poured into it. So first of all we have to see the construction, then I will explain to you that why this bottle is able to maintain the temperature of the liquid. Okay, first of all see its construction. First of all you can see this is a stopper, or simply we can say this is a cap, and we know that after pouring any liquid in it we can use this stopper. And you can see this is also a cork, and what is the use of this cork? The cork saves the glass bottle from shocks and breakage. And you can see this is the strap, it is used for holding this bottle. And now you can see the important point, that is this bottle has two walls. You can see this is the outer wall and this is the inner wall. So you can see this bottle has two walls, and now you can see this is a gap inside these two walls, and no any material is filled here. The vacuum is created here. So see carefully again, this bottle has two walls. This is the outer wall, this is the inner wall, and in this gap no any material is filled. Here the vacuum is created. So this is the construction. And also the inner wall and the outer wall, both walls are silvered or polished. So I will explain to you why these walls are silvered. So okay, now see the working. So when a hot liquid, say tea, is put in the flask, the mouth of the flask is plugged by tightening its cap. So the vacuum between the walls of the bottle do not allow the transfer of heat by conduction and convection. So as I had already explained to you, there is a vacuum inside the walls of this bottle, and you know that I had already explained to you the process of conduction and convection. So in the process of conduction and convection, a medium is required for the loss of heat. But in the case of this thermos flask, because of the vacuum is created here, so the heat cannot loss through the conduction and convection. Because of the medium is required, there is no any medium is available there. It means if the vacuum is created, that time heat cannot loss through conduction and convection. Okay, now see, next is silvered walls from inside and outside of the bottle do not allow the transfer of heat. And you can see I had already explained to you the walls inside this bottle and outside, both walls are silvered, and the silver walls prevent the heat loss through radiation. So this is the concept. So dear students, I had explained all the concepts of this chapter, so now you have to do by yourself. Still, if you find any difficulty, then you can call me also. You have my contact number. So till then, learn physics and stay healthy. Thank you.